So we talked about transactions. I keep coming back to it as like something that's really cool and available in Lakehouses. But what is it, right? So I kind of stole a picture here from a really nice course video by Dremio. Feel free to go visit it on YouTube. It's very high level, kind of talk to you about what transactions are. But as you can see, the key capabilities of transactions is optimistic concurrency. What does that mean? It means that if you have two writers and a reader that try to access the data and change the data, they're basically going to assume that their version of the data is the most recent, the most accurate. So they're going to take that version of the data, they're going to make their changes, and then they're going to apply it. They're going to commit it. If once committing it, they realize that, hey, it's actually different than what originally was there, they back off and they retry the commit with their changes. But optimistically, they're basically just assuming the world is green and the world is perfect, and they're just trying. Read isolation is really where queries point to a committed snapshot inside of the table. And you can see those snapshots as those blue metadata files. The S0, S1, S2, those are the snapshots. So after each change in Iceberg table, basically a change creates a new snapshot. So all the engines that are querying the data are looking at that latest snapshot. And the latest snapshot is pointed to by the catalog. So they're making the assumption that that is the latest snapshot that has the latest information in it, and you're just going to use it. If somebody made another commit and advance forward the snapshot, that query engine would look at the latest snapshot it was able to read and is not aware of any other changes that happen outside of that snapshot until the next time you run the query. When you write the data, it's a little bit more complicated. So the write isolation, basically there's two modes to isolate writes. First one is serializable. The other one is snapshot-based isolation. The serializable isolation is a little bit more difficult, a little closer to what databases do, where if a concurrent transaction tries to commit the data and it fails, right? A new file that contains all those rows must match the changes of the second commit. So if I have two engines trying to write the data, one of them is going to write the data, the other one is going to try to write the data afterwards or concurrently. Before it writes the data, it has to check that the first commit actually does not violate its own commit. If it violates its own commit, then it backs off and it tries to recommit its changes. And if it can't do it, it simply fails. So that's a much tighter sort of kind of isolation controls and concurrency controls. It's harder to implement. That's why a tool like Absolver will do all the writing. Having Absolver write and then having Snowflake write, having Spark write together will be much harder to coordinate those concurrent writes, but serializable isolation allows us to do that. Snapshot is a little bit more common, easier to implement. Basically says that each writer looks at the last snapshot that's available and tries to make changes and commits to that snapshot as if the whole world was just centered around them, right? So if you have two writers, each one of them picks the latest snapshot, let's say snapshot 1, they try to make changes to them completely in isolation from each other. They're not aware of who's doing what. Whoever finishes writing first, the other one is going to try to write it. And if they're successful because there's no common changes, everything's good. If they notice that they try to change the same thing, then the second writer will back off and will retry. So that's kind of how transaction at super high level work inside of Lakehouses. But with the data lake, we didn't have that concept, right? So people, so writers will step on each other. You had to manage things. You had, files being deleted behind the scenes on you and change behind the scenes. It was chaotic, and there was no isolation, no concurrency controls. With the Lakehouse approach, we have some of that now.